Hello friends, today we are going to see the beam strength of the gear tooth. So, what is beam strength of gear tooth? It may be defined as the maximum tangential load the gear tooth can bear without failure. It can be determined by the Lewis equation. For Lewis equation, there are some assumptions made. The first assumption, the effect of radial component of force, that is Fr, which produces compressive stress, is neglected. Second assumption, tangential component of force, that is Ft, is uniformly distributed over the face width of gear. Third assumption, effect of stress concentration is neglected. Fourth assumption, at a time only one pair of teeth is in contact and full load is acting at the tip of a single tooth. So these were assumptions made for the Lewis equation. Next, the figure shows the teeth of the gear, and it is to be considered that it is like a cantilever beam. Now the force F acting at the tip of gear tooth, it is resolved in two components, that is first radial component of force Fr, second tangential component of force Ft. So the first radial force Fr, this component induces direct compressive stress of relatively small amount and hence its effect is neglected. Second, tangential force Ft, this component induces bending stress which tends to break the tooth. So let M equal to maximum bending moment at section BC, which is equal to Ft into L. Ft equal to tangential force acting on gear tooth, which is in Newton. L is the length of gear tooth in mm. B is face width of gear tooth in mm. T is thickness of the gear tooth at section BC. And I is the moment of inertia of tooth section BC about neutral axis. So the maximum bending stress at point B is sigma B is equal to m into y upon I, where m is equal to Ft into L and y is equal to T upon 2, and I, that is moment of inertia, is equal to Bt cube upon 12. This gives us the equation 6 into Ft into L upon Bt square. Name it as equation 1. So therefore, for Ft we get sigma B into B into T square upon 6L. Now multiplying and dividing the numerator of RHS by M, we get Ft equal to sigma B into B into M in bracket L square upon 6Lm. Therefore, Ft is equal to sigma B into B into M into Y, where Y is Lewis form factor that is equal to L square upon 6Lm. In equation 2, as Ft is increased, the sigma B also increases. When the bending stress reaches its limiting value, the corresponding tangential force is called as beam strength. Therefore, the beam strength is maximum value of tangential force that the gear tooth can transmit without bending failure. Hence, replacing Ft by Fb in equation 2, we get Fb equal to sigma B into M into Y. This equation is called as Lewis equation, where Fb is equal to beam strength of gear tooth Sigma b is equal to permissible bending stress, m is equal to module of tooth, and y is Lewis form factor. So this is for the Lewis equation. That's it for today.